Welcome to Perspectives on Environment, Learning Module 4.6, Principles and Methodologies for Sustainable Design. We're back into a Prezi here today, and the point of the Prezi is to begin to study the interconnection and the impact of the different environmental effects that we've seen over the last few hundred years, especially through the use of fossil fuels and other chemicals. So there's a big map here. There's all kinds of information in here. I won't be covering all of it today. I know that you've had a lot of videos in this particular module, so I'm going to cut right to some of the major ones that I want to cover. Keep in mind there's a number of TEDx talks and other videos in here that are really good in trying to understand some of the impacts. I'll be hitting some of those, but others you can find in here, or you can go back to the course sites module page where I'll have those uploaded by tonight. So I argued back in the week one that we were in a black swan, one of those unique times in history where the rules are changing and where our ability to be resilient is questioned. And hopefully this lecture will further bring that home. And I show this diagram all the time, and as you know from previous lectures, this is a diagram that's used by climate deniers to try to make the point that the global warming is really nothing to worry about. It may not even be real, it's just part of a natural fluctuation. But we see more and more that the trend is moving upwards towards a region of climate or a time in climate that we've never experienced before as the human race. So what does that really mean for the planet? What does that mean for us as designers, as sustainable designers? Well, January 2014 was the 347th consecutive month of above average global temps, which I find to be significant. And if you watch the news this week, this May 2014 was the warmest May in the history of the planet if we've been keeping records. So I think that we can safely say that we know that something's happening, and we know that the science is beginning to support that. Now, it's interesting how global warming happens. It doesn't happen like this red line here as a nice clean straight shot, right? So it levels off, it jumps, it levels off, it jumps, it levels off, it jumps. So at any one point, a climate denier can say, see, the climate's not getting warmer, right? When they could take a little tiny little sample there. So keep in mind that you'll be running into people like this all the time who will try to tell you either don't worry about it or it's not really happening. And you really, if you're going to be a sustainable designer, and part of your idea of doing sustainable design, or part of your ethic or ethos, really needs to be backed up with some sort of scientific understanding at the basic level of what's happening in the climate. And hopefully this lecture will help provide some of that foundation for you. Now, as I said before, there's a number of videos in here that I'm not going to play today, but I want to let you know what's here. This is a video by James Hansen, a scientist who explains greenhouse gases and climate change very well.
A reticent Midwestern scientist.
But I'm going to go ahead and skip ahead and let you watch that on your own time. So here's why you have to be careful as a sustainable designer. There are plenty of publications out there written by people who have a lot at stake at seeing confusion continue around climate change and global warming. So here you see that the title, Peer-Reviewed Survey Finds Majority of Scientists Skeptical of Global Warming Crisis. Well, on the headline it looks pretty convincing, but when you read more closely, it's a peer-reviewed study of geological scientists who have a lot at stake in the oil and gas and coal industry. So yes, it is essentially a correct heading, but it's a majority of scientists within a specific field. So these articles are everywhere. When I do research for this course, I find so much misinformation about climate change. And remember from our example on cigarettes, all we have to do, or all they have to do, is create enough confusion to pause or delay action that could radically change and benefit society. And in doing my research, we found that that we have 2,259 peer-reviewed climate articles from 9,000 authors, and only one of those rejected anthropogenic global warming. So there's plenty of letters to the editor, there's plenty of op-ed pieces, but the actual peer-reviewed literature is convincing and conclusive that in fact the reason that our climate is changing is from our actions as human beings. And so we see that in all kinds of cycles. So for example, global warming projections vary, but they all are going in the upward direction. And so we need to keep that in mind that that's occurring. And a lot of the climate deniers will tell you, well, it's just the sun gets hotter, it gets cooler, when in fact the periodic movements or ups and downs of the sun's rays have been pretty consistent during this whole time. And so we know for a fact that we have Arctic sea ice melt, And what's interesting about that is, of course, the ice melts in the summer and then freezes again in the winter, and so climate skeptics will come and tell you, see, the ice is expanding in the Arctic. They're taking a very tiny sample of a moment in time, and they cherry pick that to create a sense that perhaps something is not really true. Um, Not sure what that is. And so for those of you who haven't looked at it, the greenhouse gas effect, or the greenhouse effect, is pretty simple actually when you look at it from a simple diagram like this. Solar radiation powers the climate system. Some solar radiation is reflected by the Earth and into the atmosphere. About half the solar radiation is absorbed by the Earth's surface and warms it. Infrared radiation is emitted from the Earth's surface. And what's happening is that this radiation here is getting trapped in this very thin layer um, that is designed to create a perfect balance, or the balance that we understand that the Earth is in. And once that heat gets trapped, it gets further absorbed not only in the Earth but really in the oceans, which is really a particular concern that we have right now. And so the more greenhouse gases that we put into the atmosphere, of course, the more that the heat will stick into our environment. And somebody will say, well, CO2 gas is only 0.03% of the total atmosphere. That might be true, but it's actually a very large part of the greenhouse gases that affect that layer. So don't be fooled by those kind of statements. Now, for those of you who hadn't thought about this much, you say, well, if we have a 2 degree centigrade rise, and 37 centigrade has been the temperature we've been at, we're only at 39 centigrade. We're only 2 degrees higher than we normally would be. What's the big deal? Well, if we translate that to Fahrenheit, we've got 98.6. If this was your kid, and this could be your kid right here, you have a kid with a normal 98.6 Fahrenheit. All of a sudden, you're at 3.6 Fahrenheit fever, which is a 102.2 fever in Fahrenheit. You would say that your kid was sick and needed to go to the doctor. And knowing that if your kid gets up to 104 or 105, you're in the hospital and you're in trouble. Well, you could think of the Earth like your kid. 2 degrees centigrade is actually a pretty dramatic rise in temperature, and really, this is a pretty dramatic time in our history of whether we're going to acknowledge these kinds of things in the widespread and move forward. So, for example, if you look at this chart, the U.S. is actually one of the only countries actually who believes that the majority believe that climate change is the result of natural causes. So you see 47% of Americans by a Gallup poll in 2010 believe that, where only 34% thought it was a result. If you look at developed Asia, for example, 76% of people believe that it's from us, and only 12% believe that it's not. Western Europe, 49% to 23%, and you see the pattern here. The U.S. really is unique in its view, and I was looking for Australia on here because I think that they also tend to be a country that denies, but let's go ahead and move on through this presentation. So carbon versus temperature, these are more of what you would see as normal charts that tell you what's called the hockey stick. So contrary to the diagram I've been showing you, there's a lot of noise here that's relatively flat, and then boom, the temperature change is rising quite dramatically, and there's a correlation. And at this point, 97% of scientists will say there's a causation between the rise in CO2 from us and the rise in temperature. And so these are things that we want to keep in mind when we get into our meetings. And certainly population growth has a lot to do with that. But not only population growth, but growth and affluence of more and more people around the world wanting to live a more comfortable, resource-intensive lifestyle. And some of the impacts of this are, for example, recent sea level rise, and we see this right around the world this year. We see all kinds of weather patterns changing, and in particular, we're seeing water molecules expanding in the oceans because of heat. And this actually happens to be the primary reason why sea level is rising, not just glaciers melting, etc. And this is of concern for many countries that live in low-lying areas. But at the same time, we're also seeing increased desertification areas of the country, and red being very high desertification, you're seeing large areas of the world becoming more drought stricken and actually drying. So we have, depending on where you are in different biomes, you're going to see different kinds of environmental impacts from climate change.